Okay, so on the subatomic particles, I just filled in the blanks from the book. Under proton is neutron and then electron. The mass of the neutron is 1.00866 with 0 charge. The electron is 0.00055 with -1 for the charge, and then the proton had a positive charge. The atomic numbers, I just looked it up with the periodic table. C had 6, Fe had 26, and Br had 35. Mass number is equal to the number of protons and neutrons. The isotope table, let's see. It was kind of a lot of filling in the blanks and going back over. So the first one, the mass number was 35 and the protons were 17 and the symbol was Cl. So we had chlorine with 17 protons, which is the same as the atomic number. The mass minus the protons is the neutrons, which was 18. The electrons were 17. Atomic number, which is the number of protons, was 17. The mass number, protons plus neutrons, is 35. And the charge is proton minus electron, which is 0. The second row, we have zinc. 30 protons, 34 neutrons. Electrons, I got 28. Atomic number, which is the number of protons, was 30. The mass number is 64, and it had a 2 charge. The third row, we have gallium. So the mass number I found was 65, which it had 31 protons. The protons are the protons.
I found the mass.
Okay, so the protons are the atomic number, which is 31, and then the neutrons, it said 34. The electrons, I put proton minus electrons equals the charge. So I had 28 electrons. I put a question mark there because I took 31 minus the amount of charge. So 31 minus 3 would have been 28. And then the atomic number was 31. The mass number is 65, and then the charge was 3. The next row, selenium. So it already told us the protons, neutrons, electrons. So the atomic number was the same as the amount of protons. The mass number, let's see, and then the charge was the protons minus electrons. And that is all of that. Let's see. So to find the average mass, I took the 0.0759 times 6.0151 plus 0.9241 times 7.0160. I was kind of confused on the rounding. I was thinking the answer would probably be 6.94, but I'm not really sure. Let's see. On naming, 2 examples, sodium phosphide, Na3P. So yeah, I just wrote down Na plus 1, Na plus 1, Na plus 1, and then P3 and just worked it out. And I did the same thing on the other side. So calcium sulfide, I got Ca, wait, I just got CAS. For the binary molecular compounds, let's see. One example, nitrogen monoxide, NO. there was one molecule at each, so we drop an O. And then sulfur dioxide, SO2. I just wrote that it doesn't need mono for the first name, and the second has 2 oxygen. That's why you use di. When naming binary acids, use the following rule. So hydro, meaning without oxygen, HCl, hydrochloric acid. So you just turn your ion ending into "ide", so hydrochloric acid. And then same thing with HBr, hydrobromic acid. The 8 or naming of oxyanions. Let's see, that would be the acids with oxygen, oxyacids. So HNO3 turns into the nitric acid, or no, is nitric acid, and then nitrate, sorry. It originally starts as nitrate, and then we turn it into nitric acid. And then so carbonate goes into carbonic acid for CO3. Wait, I can't remember how to pause this. Okay, and then let's see, the last one, this would be the oxygen acids that end in "ite". So HNO2 is nitrite, and we change it to nitrous acid. And then HCrO2 is chromite, which we change to chromous acid. And that's all.